You don't like apple pie? That's just weird. All right. I noticed you guys have like no idea what's going on. I shouldn't have to tell you that when you kind of pay attention to your surroundings here, kind of tell when we're starting, right? Yeah, this first, I think two examples you won't have any issues with. Arguably, maybe even the third and the fourth. It's on the fifth one where you're gonna be in for a little rude awakening. So let's enjoy this ride here, these first couple. So as with yesterday, I give you a literal equation like this. I can't expect you to solve it if I don't tell you what I want you to solve it for. So we're going to solve this first one for K. Once you understand the first step in this process, oh, excuse me a second here. I need to. So once we get through this first step, which you already probably know what it is, then you could solve, you'll see, for anything. So it doesn't matter. On some of the problems today, I think 1, 2, 4, 4 of them, I'm going to give you the same equation, but we're going to solve it twice because which one we choose to solve for makes a big difference. In this problem, it doesn't matter. So the first step is what it is. What do you guys think we ought to do first? Right, and that's just good instincts there. So you know if there's a fraction that our best bet is just to eliminate that fraction. So it doesn't matter that it's not a number. It's okay. We're going to multiply both sides by K like this. Right? I assume you're good with that. And then these K's over on the right-hand side are going to cancel each other out. And then we're left with a new equation that says Kx equals Y. Now, had I asked you to solve for Y, the reason I'm not having you like specifically do a problem for that is because what we've done, right? So now that you see it like this, how would you solve for K? Yeah, you would just divide both sides by X. I don't know why I wrote K. Apologies for that. Let me fix. Divide by X. And that gives you K equals what? Right. So really, you guys did a great job there. Again, good practice and instincts. You guys knew just to kill the fraction. That's going to be a big first step. So any questions on the first one? Okay. The second one, listen, I feel like you've done this before. You can write this part down if you want to, but I think in 7th grade or before that, they teach you something called proportions. So an example of a proportion would be like 5 is to 8 as 10 is to X. You've seen these before?
Yeah.
So like if Sally was making a recipe that called for 5 tablespoons of vanilla and 8 tablespoons of baking soda, and then she had 10 tablespoons of vanilla. The question is, how many tablespoons of baking soda would she need? So there's a couple ways to approach proportions. One of them is the sideways method, which will not do you any good today. The more common way, I'm sure someone taught you this, is called cross multiplication. So when you have an equal sign in between two fractions like this, you can just multiply diagonally and then set what you get equal to each other. So like if I go this direction, the answer that I get is 5x. And if I go this direction, the answer that I get is 80. And then the fact is that if two fractions are equal, then those two answers 100% of the time have to be equal to each other. And then what you get is just a nice little inline equation that you could solve. Like in this case, obviously, you would divide by 5. So we're going to apply that thinking to equations, proportions that don't have numbers in them. So for our second example, we have M is to R as P is to N. And again, this is one that I only am going to have you solve once because whether we solve for any of them, it doesn't matter. Like after the first step, you'll see we could do anything. So there's no point in doing this one more than once. But the idea here is I'm not working with it in this state. I can't. And so what I have to do first is embrace that philosophy, that idea that, wait, if I want to get this up to normal, I just cross multiply this way. What do I get? I get mn, right? And then if I cross multiply this purple way, what do I get? I get RP, and you could call it RP, you could call it PR. That's not important. But what is important is that there's an equal sign in between them. So if I said to Brendel, hey, solve for M, you go, okay, I'll divide by N. If I said, hey, Jesse, solve for R, he'd go, okay, I'll divide by P. Like, you understand that there's no deal breaker on anything that I ask you to do, right? So I just picked one, and I said at the onset of this, I said, let's go ahead and solve. When I wrote down my note card, I said, let's solve for N. So if I wanted to get N by itself at this point, what would I do? I would divide by M. I got to get rid of that M. But again, you see that that step that we just did would be identical for literally any of the four. Doesn't matter which one you pick, you just divide by the guy sitting next to him. So in this case, the M's cancel, and we're left with N equals what? Yeah, RP over M, done. And those answers, if I had you do it 4 times, they would all look exactly the same, just the letters would be in different places. Okay. And then I think this next one is where it's maybe starts to get a little bit trickier. So, and basically what I did is I took problems like off of your assignment 10 that you're going to get, and I just changed a lot of the numbers and letters. Well, more letters than numbers really, but so if you write these down and stay with me today, when you get to them on the homework, you should kind of feel like, all right, I kind of know what to do. So for this one, we have K over J equals M plus N over M. So let's go back to the last problem that we did, and let's use the exact same philosophy again. What should we do to break this open? Multiply acrossways diagonally, right? And so if I start and I head down this red pathway right here, what do I get? I get Km. And if I multiply, bless you, if I multiply this purple pathway, what do I get? I get Jm plus Jn. Very good. And that might be where your first question comes up, like, how did you do that? So if you follow the purple pathway, what we were doing, remember, was J times M plus N. And so you see that we had a couple of options there. We could have distributed like we did, or we could have not distributed. It really kind of depends on the situation. But in this case, I just figured let's multiply it out. I'm going to show you a trick to get it back out here in a little bit. If we look back at it and went, oh, I shouldn't have done that, there's a trick to go backwards, to like pull back. So now that everything's out on a line, I shouldn't have any real stress anymore. I just target it and say, okay, I'm trying to solve for J. So this is an important part of this lesson. Really important. If you're going to get lost, there's like 2 or 3 spots today. This is number 1, 100%. Do you see how by multiplying the J, we divided him into 2 places? You see that? That's a problem. Because in hindsight, if I wanted to solve for the J, look up here at the yellow, wouldn't it have been nice if the J could have just stayed in one spot for me? And then I could have just divided by whatever was next to him. So in a case like this, because the J is who I'm solving for, what I want to actually do is go back in time and erase this, and I want to write it like this. Pre-multiplication, if you will, pre-distribution. And the benefit to that is now if I said to Dallin, hey, I need you to get J by itself, he's like, I can do that because it just says J times something. So what would I do to get J officially by himself? Divide by whatever is attached to J, right? If J is multiplied by something, just get rid of that something. In other words, just divide right here by M plus N. Do you see that? So this entire chunk right here just goes bye-bye, leaving us with the answer, which is J equals Km over M plus N. Now, let's say I was doing a worksheet like the one I'm about to have to do, and I looked at my options, and that wasn't one of my options. Can anyone see something that maybe we could have done differently? Maybe we could look at our answer and say, because that's a big thing with something like the ACT or sometimes the YTOP or a worksheet like this, is I can't just sometimes submit an answer. I have to pick from a list of choices. And I feel at this point like we haven't done anything wrong, but let's say that that's not one of my options. Does anyone spot anything? That's okay. I mean, yeah, that's kind of part of the issue here. Let's assume this is going to be one of our options though. So let's move on from that question because I think that that answer that I'm thinking of is going to get a little bit convoluted. So everyone okay with that so far? Now, what I want us to do is leave. We're going to do the same problem again, but we're going to solve for something else this time. So this time we are going to solve, instead of solving for J, we're going to solve for N. I hope after this example, you understand the difference between when I should actually distribute something and when I shouldn't. So I kept my red and purple lines up there because we're still going to begin the problem the same way. So if we follow the red pathway, what do we get again? And if we follow the purple pathway, what do we get? Yes. And if I were to have left it unmultiplied, I'm going to write this in purple for you. If I had left it like this would be a really big problem. It wouldn't work because the N that I'm trying to solve for is in jail. And N's like, you can't solve for me if I'm locked up in a set of parentheses. So in a case like this, it's the exact same problem, but if I ask you to solve for N, this time we would want to multiply it out because we want the N to be free, which he is. If you look at what I've written in white, N is free. Yeah, he's got a pesky J attached to him, but not worried about that. So know the difference between when should I multiply and when shouldn't I. It depends. Do I want something to be free or am I okay with it being grouped up? You with me, Hagen? That's good. Yeah. You sure?
Yeah.
Oh, cool. Anyways, now that you see what's written in white at the bottom, you shouldn't have mechanically any troubles with solving for N. What would we do first? You need to physically remove this term from the side of the equation that we want to play with. Eventually, we want to divide by this J with the arrow pointing to it, but we can't do that yet because this whole term is blocking up the works. So the next thing we're going to do is move the JM to the other side. We're going to have KM minus JM equals JN. And at this point now, if I said solve for N, you wouldn't hesitate. What do you do? Just divide by J. Now, when I asked my question at a poor time as your teacher, I kind of messed the order of that up a few minutes ago. This is the question I was thinking of. Let's say I was taking a test or doing a worksheet, and I feel good about what I've done, but I don't see an answer that matches this. You could, in a case like this, take this J and this J and cancel them out just like that, and that would leave you with this. Km over J minus M. All I did was in this, I'm going to put a red box around it. In this problem right here, I just simplified that half of the problem, which is legal when there's two on top and one on bottom. You can pick and choose which fraction you want to reduce. So you could get that equals N, of course. So far, okay? All right. Because in the purple box, he's still alive. So he didn't cancel in the purple box, but he did cancel in the red box. So that's just, it's like a partial division problem. Like you can divide one way or the other way or both, but in this case, only the red box yielded any progress. You guys okay? All right. Which ones? Because they're not like terms and they're not like above each other or anything like that. So this one has a K and an M and this one only has an M. So they're certainly not like terms or anything like that. And the only reason I could divide those J's is because they were above and below. They're like a fraction to reduce. Make any sense? Okay. All right, this is where I think it gets a little bit scary. So if you're already super lost, sorry. This one we will also do twice. The first time we're going to solve for W. This will be one of the harder math problems that we've done. So first thing, we have to go back to our 4th grade, 5th grade fundamentals and ask ourselves, whoa, we have to kill fractions. But in order to kill the fractions, as you know, we have to find a fraction killer that will reduce or divide them all. Can anyone think of what the fraction killer is? Yes. That's good math. Good math. Good number sense. If I were to multiply by something that has all 3 of them in there, every time I go and do the hook, something will cancel. The bottom of the fraction will cancel. So like you look at the first fraction and say, if I'm going to hook out the bottom of this first fraction here, this purple one, whatever I multiply by has to have an M. So if you perform this first purple hook right here, what happens? When the M's cancel, what does that leave? It leaves NW. And if you multiply that leftover NW by the top, you get NW times 1, which last I checked is NW. Bring down the plus sign. Now take a look at the green. I am going to eliminate the second fraction. So I'm going to multiply M and W across by hooking. So I'm going to cancel downwards. When the N's cancel, what does that leave? MW times 1 is MW. And then finally, follow the yellow. I'm trying to eliminate this fraction, but my toolkit that I brought contains a little of everything that I need to kill all of the fractions. So when I perform this long yellow hook, the W's cancel, and what does that leave? Times 1, which is MN. Did that make any sense at all? For real? Are you just lying? Are you making me feel good on a Tuesday? Oh, that is great news. Now comes the scary part. I have to teach you something at this point. Listen, when we do factoring in April, that's going to be like next level. And then if you decide to take my Algebra 2 class in a couple of years, then the factoring gets out of control. But for today, I have to teach you a very basic type of factoring. And what it is the distributive property backwards. So follow along here. I'm going to write over here. I'm going to actually make a new page, and I'm just going to write some things down, and you tell me if what I'm saying is crazy, please. Okay? If I gave you MR plus KR, can you think of what distribution problem would have had to happen to make that be an answer? R would have had to multiply through what? M plus K. If you can do that, what you just did is called factoring. It's called a greatest common factor. It's literally doing the distributive property in reverse. If I can distribute, I can undistribute. How about this one? AC minus AB. What would we pull out, essentially, if you will? They both have A, and what does that leave? You guys with me on that? If that went well, then today's just got better because that's the part that scares me. You good with that? All right, let's go back to the other page. So here we find ourselves in a situation where someone's telling me to solve for W. Now, this is a problem for me because W is in two different places. You see how he's right there and right there. And going back to a question I've heard before, why can't I just put these two terms together? They're not the same. Yeah, they're not like terms. One is two different letters. I mean, they're not the same. Yeah, they both have W's, but they're not the same. So I can't just mash them together. So what I have to do is that trick I just showed you. I have to do factoring. I have to take that W. Since I want to solve for him, I hope you're paying really close attention because this trick's going to get you through a lot of problems. And I have to pull him out. I say, W, if you're in two different places, I need to collect you into one place so that I can solve for you. And that's what the factoring does. So I'm going to take this W, and I'm going to pull out a copy in front like this, W times. And what will be left over? N plus M. And what a powerful bit of mathematical ingenuity that is. Because now, if I say, hey, solve for W, you just divide by N plus M. That one scares me. Did it scare you, or are you guys just too strong for that? Was that good? So the answer is, once I scribble these out, then the answer is simply W equals Mn divided by N plus M. Feel good? Okay. We're going to do the exact same problem again, but we're going to solve for something else. I will say, you know, how we begin is not going to change. So let's start over. 1 over M plus 1 over N equals 1 over W. So remember the fraction killer? What was he again? Nice job. MNW. And as you hook through this, you start to realize all you're doing is just pulling one out and leaving the leftover. So on the first hook, what's left? On the second hook, what's left? And on the third hook, what's left? Good job, you guys. Now, this time I want you to solve for N. Do you see why that's a problem? There's two problems. Problem number one is there's two N's. Problem number two is what the who. One of them is over there and one of them is over there. Can any of you big brain maniacs think of a way to fix that? Nope. Remember the last problem? You remember how convenient it was when I had you solve for W's? Let me erase these arrows and point to something here real quick. Nope. You remember how the W's were on the same side and how cute and nice it was when we could just pull them out? My issue with you right now is, hang on a second, pump the brakes. Sorry, but you're asking me to solve for N, but he's on two different sides. Can we remedy that? Quit trying to multiply. Can we remedy that? Can I get things to move to different sides of equations? Subtract one, move it. By this point, October 17th, we should feel free to have terms move about the cabin. Here's what I think. I think to myself, MN, I'm sorry for the disruption, but I'm going to need you to go over there and join the other term that has the N in it. Would you do that for me? And MN's like, sure, I'll just subtract myself across. So the problem then with that is MW says, well, I see you guys are having a little get the ends together party. I guess I'll show myself out. And so then MW has to move back across this way. Having said that, the only guy that doesn't move is Northwest here. NW says, I'll just hang tight while you idiots do your little ballet. When MN, the purple guy, comes over, he is now minus MN because he moved, right? And what is the yellow guy, MW, when he's now on the right side? Say it again. Negative MW. Now, that's just a simple little cute song and dance. If you don't like something on the left side, move it to the right side. If you don't like something on the right, move it to the left. You're always welcome to do that as long as you remember to change the signs. And now when I say to you, I want you to solve for the ends, you go, no problem. because they're right next to each other, just like I want them. So let's do that cute little trick. What do we do to consolidate the ends into one spot? Oh, sorry, I didn't mean to write M. My apologies. N times what, Brendel? Good job. And now I feel like I can finish this. If you want me to solve for N, what do I do? I just divide by whatever is stuck to my guy, N. So I'm going to divide by W minus M on both sides. Cancel those out, and you're done. N equals negative MW divided by W minus M. If that problem is not difficult for you, that is a real testament to how far you've come, because that is not light work. Solving 3x minus 4 equals 11 is light work. Understanding how to switch inequality signs is relatively light work. That is not. That's some next level algebra. Still good? You guys are amazing. On to the next one. You okay? Is you a little sleepy? Too much TikTok last night? Seriously? That's too much sleep. That could be your problem. If you go to bed at 8, that could be too much sleep. After you go past like 8, 9 hours, your body's just like, that's too much. 6 is the sweet spot. Scientists say 8. I say 6. 6 is just a banger number. Bam. 6 hours. I'm not going to tell you your business. I'm no doctor, but I think 6 hours is the sweet spot. All right, next one. X equals a fraction, okay? So on the top of your fraction is going to be y times m plus n. And on the bottom of your fraction is going to be a 3. And this is one that I only want you to do once, and I'll show you why. We're going to solve for m. You should already see a problem. If this is going even remotely well, why don't we like M right now? He's in jail. He's blocked. He's stuck in there. He's like, I'm sorry, I'm in this little hut that you wrote for me, so I can't really do anything. But we can fix that. So step 1, though, is what? No. Multiply by 3. Step 1 should just instinctively be to multiply by 3. We can't have this fraction gumming up the process. So these 3's over here are going to die. And now we have a brand new problem that says 3x equals y times m plus n. The reason I did not have us do this problem twice in the notes is because of this. And I don't feel like we have to do this twice. If I said to you, solve for y, you're basically done, right? What would you do? You divide by m plus n. Game over. I don't think that's worth its own taking up space in your notes. That's easy. So that's why I wanted us to solve for m. And for the record, I don't need to do m and n because the process is going to be the same. But how does this process begin? Distributing is a great answer to that. That is definitely one of the options. And so I feel like if m is in there going, listen, you got to get me out of here. Get me out, like free me, break me out of jail. I have a tool for that, and that tool is called distribution. So if I take the y and I put it through, there's no more prison. M is no longer locked up. So now I have 3x equals ym plus yn. Now you can do whatever you want. We've seen this some version of this equation like 5 times now today, where everyone's out in the open. You move whoever you want to wherever you want, divide by whatever you want. I don't care. Since we're solving for m, I'll point to him and put a little target on him. Boom, that's my guy. So what has to happen first? Yeah, you got to take this whole term right here that I'm putting a little oval around, and you have to first show him the door. Say, could you clear out the workspace here so I can divide here in a minute? So we're going to take that yn and move it to the other side. And when we move it to the other side, what does he become? Minus yn. Very good. You see, we just craft this by getting who we want to be alone closer and closer and closer. And then we simply divide by y. Good. And again, this answer could be written multiple ways. So one option would be to write this answer as m equals 3x minus yn over y. Perfectly fine. But let's say you're taking the ACT. And you go, oh, shnikes, that's not one of my options. You can use the little partial division trick right here to cancel those y's, right? And then your answer would be 3x over y minus n. And again, if you ask why did I cancel one way and why is the y still there, it's because there's a red box, which I did not touch. And then there's a purple box in which I did cancel the y's. Follow? You okay? Yep. Good question. Yes, I would take either on a quiz because my quizzes are open-ended. So yeah, good question. Great question. Yes. Neither one to me is any better than the other. You guys ready for the home stretch? I have 4 more. And then, like I said, at the end of this, I promise you work time for whatever's left today. And then, of course, all tomorrow and probably all Thursday. So this will be the end of the learning stuff. And then you just get to put it into use. So for this one, I have A equals x over y sub 1 minus x over y sub 2. I had to put this in one of my examples because there's no way we make it through this without someone freaking out. So those little numbers at the bottom, they're called subscripts. They mean absolutely almost nothing. A lot of times in mathematics, like you'll see, have you guys seen the slope formula from Mr. Manlove? Do you guys remember this? Don't write this down. Slope equals y sub 2 minus y sub 1 over x sub 2. You guys, have you seen that before? Yeah. That just means take this y minus this y and take this x minus this. Like they're different labels for different versions of something. So we think of them as different variables, essentially. But I just wanted to get this in one of my problems so you didn't go, what are those? They're not exponents, they're labels. That's all. So I want you guys to help me do this problem twice. First one is going to be, we're going to solve for x. Big brain question incoming. You're amazing. It makes me so proud when we work so hard for 8 weeks and then you say something like that. It's so marvelous. Yes. Fraction killing, next level brain work going on over here. Yes, that's exactly what we do. We multiply by y1, y2, just like that. Absolutely makes me proud. When I want to kill a fraction, I need to bring a fraction killer that can cancel both fractions. I pack it in, whatever I got to do. So here we go. Purple arrow first. What is the answer to the purple arrow? Any order doesn't matter. Just follow the purple arrow and multiply. What do we get? You get y1, y2, a. Remember, multiplying, it's you just mash stuff together. If they're all letters, you just blew them up. Does the order matter? Nah, I don't care. You could put them in any order you want. Now, yellow arrow time. Watch out. Do the hook. You got this. Ready? When you hook down here, follow the little yellow arrow. Who cancels? The y1s go away. And what does that leave us with? You guys are amazing. Amazing. Excellent. And finally, let's go green arrow all the way across. Follow the green hook arrow. When the hook comes down, who cancels? Leaving us with, so minus y1x. Make sure you bring your minus sign down and then bring down all the stuff. Got it? You good? Now, since I want you to solve for x, we got to use that dope new trick we learned today. Do you see how the x is a problem? Because he's like, hey, look at me, nanny, nanny, boo, boo. I'm in 2 different places. You go, I got this. What do we do? You guys are amazing. You pull that sucker out, man. You make 1 copy of him. Look at you guys. This is unbelievably next level, and you're just handling it like champs. To get x by himself now officially, what would we do? Done. X equals. Or if you're like Addie, who remember yesterday asked, is it okay if I keep putting my x on the left? Let's switch it once for any of you guys who like it this way. So I could just write x equals and then just copy all the stuff over to the other side. So I could do y1, y2, a divided by y2 minus y1. Done. Game over. Fire away. No, nothing's going to cancel in this case. Partial division, that trick I showed you, does not work when there's a single thing on top and two things on bottom. It has to be doubles on top and single on bottom. So that's why my question earlier was out of place. So still good? Yeah. Same problem again. Sorry, you guys are amazing. I know you got to just be so done, but let's get this all done. We got 3 more. We're going to make it. Same problem. A equals x over y1 minus x over y2. And this time I would like you to solve for y1. We're still going to multiply the exact same way. We're going to multiply by y1, y2. The fraction killing is a non-negotiable. Let's go playing with colors again. Purple arrow. Once again, what do we get? Nice job. Just glue them together. Okay, let's go again. Green arrow, please. What do we get? Good job. And finally, yellow arrow. What do we get? So minus y1x. So the same step happens, right? I'm sorry to make you write that again, but we're going to get to here no matter what we're trying to accomplish. Since we're trying to solve for y1, in this case, I have to, again, utilize a trick, don't I? Do you see how y1 is in 2 different places? So what I basically am thinking is this, and you tell me if you disagree. I don't ever mind if you disagree. I'm thinking if I can take this yellow guy and go stick him right next to his homie right there, wouldn't the y1s now be on the same side? Yeah. And then I wouldn't have to move this red term, right? Because he's already on the opposite side. So choose your path wisely. He's already on his own side, right? So if I move the yellow box over to the left side, my left side now says y1, y2a plus y1x equals y2x. And if that looks like a mess, you've just lost your focus. The whole point is that my y1s that I want to get out are on the same side, and now I can do my dope little trick. And what will that be? Pull this and this out. What do we get? Undistribute the y1. You get y1, and what is he distributed into? y2 times a plus x. I see you got a little bit lost there, perhaps. If you go to this term, I'm going to underline it in purple, or this expression right here, I'm underlining it in red. Do you see how there's a y1 in both of them? So if I take that y1 and undistribute it out away, all I simply do is copy the leftovers down. So what's left of this first term is right there. And what's left of this second term is right there. Do you see? Whoa, about sums it up. I agree, bro. And of course, what's the last step? Yeah. So we get a final answer of y1 equals y2x divided by y2a plus x. As we say in Rocket League, when someone does something amazing, holy cow. If you walked in today and saw that on the board, you might have been like, yeah, this is going to be a long day. You guys got this. Smokey and the Bandit. Wow, that's a... All right, guys, last problem. Sorry, we're going to do it twice. You good? You got this? Go to a restaurant and eat. Celebrate our success with some tacos. Enchiladas. That's what I should do. I should call Taco Bell and say, first hour, we got about, could you bring us 120 tacos? Yeah, that'll be $240. And maybe I just don't know what page it was on. That's... Sure. Where my yellow and green are? Where my yellow and green boxes are? Oh, I knew that. I even knew it. I even knew. I said to myself in my mind, I said, hey, Jeremy, show your work. And then I thought, I've shown it on every step. I'm just going to branch out. Gosh, dang it. I'm trying to get this purple arrow thing by itself. So all I simply did was divide both sides by everything that's attached. I knew I should have shown it. Do you see how I just divided by all the stuff that's attached to Y? That's all I did. I'm sorry I didn't show that. I know, and I went rogue and I should have known better. Last problem. If you guys ever need to go back, you can always just go back and get on the YouTube video, fast forward. It'll take you like 30 seconds to get there, and just fast forward till you get to the example that you want. So try not to go too fast, but if I lose you, just know you can always go back. Like this will exist historically on the internet. You can find it. Well, no, because I mean that would mean we have to do F and G and H and all that stuff. So no, I did think this would be nice, right? 5 letters. Let's start by solving for C. Yeah. Again, my issue with C is that you're trapped. And so I can untrap anything by using something called distribution, right? If you haven't gotten that memo yet, distribution is pretty awesome. So I'm going to take this B and I'm going to multiply it through. So follow along now, and please ask if you don't know how I get what I get. The answer to the first one is BC over D. Because B times C over D is B over 1 times C over D. And that's why we get BC over D. Okay? You can't double distribute a whole number like that. And then, of course, follow the purple arrow. This one's easy. What is the purple arrow equal? Minus. We're almost there, okay? Yeah. No, ask your question. It's okay. I would take multiple different answers. Problems like this, you guys are pretty powerful. You sometimes you go down a pathway and realize I should have maybe chosen the other pathway. I didn't do anything wrong. I just could have done this differently. What do you guys think we should do next? Yes, that's fine. That was one of the answers I would fully accept is why don't we just get this out of here right now? Because we know he's in the way, because our target is right there with the arrow, right? So the target is there. So I want this whole term to go bye-bye. So I don't mind that at all. I like that strategy. So on the left side now I have A plus B E, right? And then I'm left with BC over D. Now, no, I'm just moving things across the equal sign. Yeah. That's a real strong algebra move, is just to juggle things around. Dallon's like, I don't like X over there. Fine, move it over there and make it negative. I don't care. You don't like the -5 over there? Good, move it over there and make it +5. Like you just juggle terms all day long. Move them, move them, move them. Put them where you want. Now this one is really not up for debate. What has to go now? We got to get rid of that D, and how are we going to do that? Good, so we're going to put on some monster brackets, and we're going to multiply by D. Now, how I write this again is going to kind of depend on the nature of the multiple choice option that I have. So in my case, I could distribute it if you want to, and that's fine. So I could write this side as DA plus DBE. You guys see what I did? I just took the D and I multiplied it here to get DA, and then I multiplied it here to get DBE. And then finally, my God, we made it. What do we divide by? I'm just B, because we're trying to get C by itself. So just divide by B and cancel those out, and we're done. This would be one where you could come in and cherry pick out that B in the second part. So like if you were taking the ACT and this wasn't one of your options, you could cherry pick right there. See that little arrow, that vector I'm pointing? Those B's you can target because the double's on top and the single's on bottom. So if you didn't see this answer, you could alter it a little bit. It would be DA over B plus DE. So let's go back in time because I know I can only imagine how over this you are. Like I could imagine it, and I'm sure I'm still off by a factor of 1,000,000 as to how over this you are. So the other example that I wanted us to do was to solve for E. So let's go back in time. I can cheat a little bit. I can use the rewind button. And I'm going to get us back to here. Marvelous. I'm really glad to hear you say that you don't think this is difficult. And I know you might think that I'm a big cheese ball, and I really don't care. If you don't think what we're doing today is hard, you have no idea maybe how proud you should be of yourselves for that. How much work you've had to put in to make that not be difficult. I'm not Mr. Blow sunshine motivational speaker. I speak the truth. I mince no words. If I'm unhappy, I'll tell you. In this case, if you don't think this is hard, you guys are amazing. For real. If I asked you guys to solve for E, this is our last math problem, I promise. I like what Morgan is saying over here. Morgan is saying, why don't we go ahead and get rid of the fraction? And I don't disagree with that sentiment at all. So since our entire working is going to be more comfortable from here on out, if we do this, why don't we just take a quick moment and multiply by D? It's worth it because now everything's going to be in a line and we can just add and subtract and divide to our heart's content. So good thinking, Morgan. That's what I would do too. So right here, purple arrow, what do we get? And then right here, green arrow, what do we get? Just BC, because the D's canceled out. Great job, you guys. And then finally, right here, yellow arrow, what do we get? Minus DBE. And if I said to you now, land and get E by itself, he'd say, okay, I can do that. But give me a moment, please. I got to move some things around. Go big brain mode on me here. Who should go? Sure. Option 1 is to move the BC. So I could take the purple box and man, if you're not good at this yet, get good. You've got to learn to just pick things up and place them elsewhere. So I could say, BC, you're up in my business. So get over to the other side and make yourself a minus. And BC's like, done. What am I left with on the right? Negative DBE. This would be a good time for you to ask a question like, hey, in hindsight, could I have moved the minus DBE to make it positive? Sure, move whoever you want. I don't care. And finally, thank God we made it. What do we divide by? Say it again. Negative DB. Very good. And we could clean this up, certainly, but this will do because I know that you are done. So our answer in this case can be negative, and then we just write the fraction dA minus BC over dB. Notice how I just took the negative and went whoop and pulled it out. You guys made it. The rest of the day today, which is literally nothing, is pointless. All of tomorrow will be work time, and all of Thursday will probably be work time. You guys got it? All right.